What's the most violent event in the entire universe? It's not a star exploding in a supernova. It's not even a gamma-ray burst shooting across the cosmos. It's something far more powerful, something that literally shakes the fabric of space and time. I'm talking about the collision of two black holes. Black holes are already the most mysterious and extreme objects we know of. They're born from the death of massive stars, which collapse under their own gravity into a single, infinitely dense point called a singularity. Around this point is the event horizon, the famous point of no return. Once you cross it, nothing can escape, not even light. The more massive a black hole is, the stronger its gravity, and the more it warps the space and time around it. Now imagine two of these cosmic monsters finding each other in the vastness of space. This is called a binary black hole system. They begin a slow, deadly dance, orbiting one another. As they circle closer and closer, they start to lose energy. But how? They release it in the form of gravitational waves, ripples in the very fabric of space-time. Albert Einstein predicted these waves a century ago, but we only first directly detected them in 2015. It was a monumental discovery that opened up a whole new way to see the universe. As these two black holes orbit faster and faster, the gravitational waves they produce become stronger and more frequent. Think of it like two skaters spinning on ice, pulling each other closer until they're a blur. The closer the black holes get, the more violently they shake the cosmos. This is the in-spiral phase. They're moving at incredible speeds, spiraling inward until the final catastrophic moment of collision. When they finally merge, the energy released is almost incomprehensible. For a brief instant, the collision unleashes more power than all the stars in the entire observable universe combined. But this isn't an explosion of light. It's an explosion of pure gravity. This tremendous burst of energy is carried away by those gravitational waves, which travel outward at the speed of light, stretching and squeezing space itself as they go. If we could somehow see this event with our own eyes, it would be a flash of invisible force, powerful enough to move planets and stars across billions of light years. So what happens to the black holes themselves? The two singularities merge to become one. A new, single, even more massive black hole is born. Its mass isn't quite the sum of the two originals, though. A small fraction of their combined mass gets converted directly into that immense burst of energy that creates the gravitational waves. Following Einstein's famous equation, E equals mc squared. This new black hole is often left spinning incredibly fast, a result of the angular momentum from the cosmic collision. The space around the merger is thrown into chaos. Any nearby stars or gas clouds are violently tossed around by the gravitational upheaval, like ships in a cosmic hurricane. Could a collision like this ever affect us here on Earth? Well, the good news is, probably not. For a black hole merger to have any noticeable effect on our solar system, it would have to happen incredibly close to us, astronomically speaking. The gravitational waves from distant collisions, even those billions of light years away, are passing through us all the time. But by the time they reach us, they are so faint that they distort space by only a tiny fraction of the width of an atom. We are completely oblivious to them. But for astronomers, these faint ripples are a goldmine of information. Using incredibly sensitive detectors like LIGO and Virgo, scientists can hear the cosmic chirps of black holes merging across the universe. These signals allow us to study the most extreme environments imaginable, learning about the mass, spin, and distance of these colliding giants. It's like having a new sense to perceive the universe. There's another fascinating part of this process called the ring down. After the two black holes have merged, the newly formed larger black hole doesn't just settle down immediately. It's distorted and unstable. It wobbles and vibrates, like a bell that's just been struck. As it settles into its final, stable, spherical shape, it releases more gravitational waves. By studying the frequency and decay of these ring-down waves, scientists can test Einstein's theory of general relativity with unprecedented precision. Each collision becomes a natural laboratory for exploring the fundamental nature of gravity itself. So what if a black hole collision happened right next door? The immediate vicinity would be utterly destroyed. Stars would be torn from their orbits and flung into interstellar space. The surrounding space would ripple and warp violently. It would be an event of pure cosmic destruction. And yet there's a strange beauty in this violence. It's a powerful demonstration of the fundamental forces that shape our universe. A black hole collision isn't just a random accident. It's a key part of the cosmic life cycle. Two black holes meet, they merge, and something new is created. The space around them is forever marked by their encounter, a silent testament to the immense power of gravity. While we may never witness one of these events up close, our incredible technology allows us to feel their echoes from across the cosmos. Through gravitational wave astronomy, we are peering into the heart of these cosmic cataclysms, events that were once purely theoretical. So the next time you look up at the quiet, peaceful night sky, just remember, it's not as calm as it looks. Somewhere out there, in the dark voids between the stars, cosmic titans are locked in a final embrace, colliding and merging, shaking the very foundations of space and time. It's a humbling reminder that the universe is far more dynamic, violent, and awe-inspiring than we can ever fully imagine. Thanks for watching. If you enjoyed this journey into the heart of a cosmic collision, don't forget to like this video and subscribe for more deep dives into the mysteries of our universe. See you next time.